Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss one more numerical question on shortest remaining time for scheduling algorithm. These kind of questions will help you to understand the concept in a better way. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. Three processes such as P1, P2, P3 with execution time as 20 units, 30 units, 10 units respectively. Each process uses first 20% of execution time in CPU, then 50% in IO, then remaining 30% of execution time in CPU. Find the average waiting time using shortest remaining time for scheduling algorithm. Now, any scheduling algorithm will have two parameters. One is the criteria and another one is mode. Now, let me discuss about the criteria and mode for the shortest remaining time for scheduling algorithm. The criteria is burst time. Okay. And the mode is, we have two types of scheduling algorithms. One is non-preemptive scheduling algorithm and another one is preemptive scheduling algorithm. The shortest remaining time for scheduling algorithm comes in the category called preemptive scheduling algorithm. Sometimes they will give you as shortest remaining time for scheduling algorithm, or sometimes to confuse you, they will give you as preemptive shortest job for scheduling algorithm. Even if they mention preemptive shortest job for scheduling algorithm or shortest remaining time for scheduling algorithm, we have to follow the same strategy. Okay. So with this information, let me solve this question. Now they have given the three process. Now let me draw the table for you. Okay. We have three process such as P1, P2, P3. Arrival time they have not mentioned. So we will consider the arrival time as 0, 0, 0 and the order of arrival is P1, P2, P3. And execution time of process P1 is 20 units, process P2 is 30 units, process P3 is 10 units. Now this execution time 20% is first for the CPU burst time, then 50% is for the IO burst time, and then remaining 30% is the CPU burst time. Now let me compute the CPU burst time, IO burst time and CPU burst time for the process P1, P2 and P3. So 20% of 20 is 4, 50% of 20 is 10, 30% of 20 is 6. If you have a doubt, 4 plus 10 is 14, 14 plus 6 is equal to 20. Similarly, process P2, 20% of 30 is 6, 50% of 30 is 15, 30% of 30 is 9. So 6 plus 15 is 21, 21 plus 9 is 30. Now process P3, 20% of 10 is 2, 50% of 10 is 5, 30% of 10 is 3. So 2 plus 5 is 7, 7 plus 3 is 10. Okay, so let me draw the lines for making it clear. Okay. Now what they asked, we have to compute the average waiting time. If we want to compute the average waiting time, first we need to complete the finding the completion time of each process. So to do that one, I need to draw the Gantt chart. Okay, always the Gantt chart will start from 0 units of time. In a process state diagram, we will have 7 states such as new, ready, running, terminated, wait, suspended wait and then suspended ready. Out of these 7 states, to make you understand this concept, I will use the 3 states such as ready, running and then wait. Okay, is it clear for you or not? Now at 0 units of time, process P1, process P2, process P3 are there in the ready state. Now as it is the shortest remaining time for scheduling algorithm, the criteria is the burst time. So we need to find the burst time of process P1, process P2, process P3. The burst time is the CPU burst time. So 4 plus 6 is 10. 6 plus 9 is 15. 2 plus 3 is 5. Now, which one has the less burst time? Process P3. So, process P3 will be dispatched to the running state. Okay, is it clear? Are you able to understand? So, process P3 will be dispatched to the running state. Now, look at here. As it is a preemptive scheduling algorithm, first it will run for 1 unit of time. Okay, now if it runs for 1 unit of time, its remaining burst time will be 4, and this burst time is 10 and 15. So even process P3 has the less burst time. Is it clear? So P3 can run for another 1 unit of time. If it runs for another 1 more unit of time, the remaining burst time of process P3 will be 3. Process P2 and process P1 is 10 and 15. So again process P3 has the less burst time. But however, if you look at after 2 units of time, process P3 needs the IO request. And to grant that request or to complete that request, it needs to spend 5 units of time. Okay, so process P3 will be going to the wait state at 2 units of time. Okay, and it need to spend 5 units, so it will come back to the ready state at 7 units of time. Is it clear for you? So if process P3 went to the wait state, process P1 and P2 are there in the ready state. Now among P1 and P2, one process has to go to the running state. Now which one has to go? Based on the burst time. Process P1 burst time is 10, process P2 is 15. So which one has the less burst time? Process P1. So process P1 will be scheduled to the running state. Okay, so process P1 will be dispatched to the running state. It will run for how many units of time? You look at here. If I run for 1 unit of time, okay, its remaining burst time will be 9. So we will run it. Okay, are you able to understand? Then its remaining burst time is 9 units, and this one is 15 units. So still process P1 has the less burst time. We'll run for 1 more unit of time. Okay, 4. Now this remaining burst time is 8, and this one is 15. So still process P1 has the less burst time. So we'll run for 1 more unit of time. See, as it is a preemptive scheduling algorithm, I am doing it 1 unit at a time. Okay, so now process P1 has completed for 3 units of time, so its remaining burst time is 7 units. Process P2 is 15, so still process P1 can run for 1 more unit of time. Okay, now process P1 has run for 4 units of time. Its remaining burst time is 6 units. Process P2 remaining burst time or the burst time is 15 units. Then you can say that process P1 can again run. But look at here. After executing for 4 units of time, process P1 will go for the wait state. So process P1 will go to the wait state at 6 units of time, and it needs 10 units of time. So 6 plus 10, which will be 16. So process P1 will come back to the ready state at 16 units of time. Is it clear for you? Now only one process is there in the ready state. So process P2 will be sent to the running state. Okay, and process P2 will run for 1 unit of time. Okay, is it clear? So process P2 remaining burst time is 14. Is it clear? Because total burst time is 15, 1 unit it has run, its remaining burst time is 15. Now at 7 units of time, process P3 will complete its task at the waiting state. It will come back to the ready state. Now process P3 is there in the ready state, process P2 is running in the running state. Now we need to look at the burst time of process P3 and P2. What is the remaining burst time of process P3? Is 3. Is it clear? Are you able to understand? So as it is a preemptive scheduling algorithm, we need to look at the burst time which is there, burst time of a process which is there in the ready state and running state. Now the process which is there in the ready state has a less burst time, so we have to do the context switching. So meaning is that process P2 will send to the ready state. Okay, process P3 will be dispatched to the running state. Okay, process P3 will run for 1 unit of time. Is it clear? Are you able to understand? Then its remaining burst time is 2 units. Still it is less than the process P2. So it will run for 2 more units of time. Okay. And it will complete its task and will go to the terminated state. Okay. Process P3 is done. Now process P3 has gone to the terminated state. Okay. Now process P2 is currently in the ready state. Process, okay, P1 will come out from the wait state at 16 units of time. So still it is 10 units of time. So process P1 is there in the wait state. Process P2 is there in the ready state. As only one process is there in the ready state, it will be dispatched to the running state. Okay. Now process P2 remaining burst time is 14 units. Am I right? Because total burst time is 15. We have run the process P2 till now only 1 unit of time. So process P2 remaining burst time is 14 units. So process P1 will come at 16 units of time. So process P2 can run for 5 more units of time. Is it clear? We will run it at 15. Is it clear? Now look at here. Process P2 can run for 6 units of time. Then it has to go for the IO burst time. So here it has run for 1 unit of time. Here it has run for 5 more units of time. So it has completed its first round of CPU burst time. So process P2 also will go to the wait state at 15 units of time, and it needs the IO burst time of 15 units. So it has to come to the ready state at 30 units of time. Okay. Now both the process such as P1 and P2 are there in the wait state. So CPU cannot perform any operation. So it is idle for 1 unit of time. Is it clear? So here the CPU is idle. Are you able to understand? At 16 units of time, process P1 will come to the ready state. As only one process is there, without looking the burst time, we can dispatch the process P1 to the running state. Is it clear? Now process P1 remaining burst time is 6 units. So process P1 will run for 6 units of time. Even it is a preemptive scheduling algorithm, the process P2 is there in the wait state. So no process is there in the ready state to compete with the process P1. So process P1 will run for 6 units of time. So at 22 units of time, process P1 has completed its task. Are you able to understand it or not? So it will go to the terminated state. But however, process P2 will come to the ready state at 30 units of time. So again, CPU is idle till 30 units. So now CPU is again idle for 1 unit and 8 units. So totally we will find how many units of time CPU is idle. Now process P2 will come to the ready state at 30 units and it will come to the running state. And it needs 9 units of CPU time. So process P2 will complete its task at 39 units of time. So they may ask you how many clock cycles or how many units of time CPU is idle. So it is 1 plus 8, 9 units of time CPU is idle. Is it clear? So we have drawn the Gantt chart. Now we can easily compute the completion time and turnaround time, waiting time and average waiting time. So completion time of each process, P2 is 39, P1 is 22, P2 is 15. Okay. Then turnaround time is completion time minus arrival time. 22 minus 0 is 22, 39 minus 0 is 39, 15 minus 0 is 15. Now they asked us to compute the average waiting time. So I need to compute the waiting time. Waiting time is equal to turnaround time minus burst time. Here burst time is CPU burst time only, not the IO burst time. So which will be 22 minus 4 plus 6 is 10. So which is equal to 12. And this is process P2 is turnaround time is 39. CPU burst time is 15. 6 plus 9 is 15, which is equal to 24. And process P3 turnaround time is 15, CPU burst time is 5, so which will be 10. Okay, so we got the waiting time. Now we need to compute the average waiting time. Average waiting time is equal to waiting time of all the process summation by number of process, which is equal to 12 plus 24 plus 10 by 3, which is equal to 36 plus 10, which, sorry, yes, 12 plus 24 is 36, 36 plus 10 is 46, 46 by 3, which is equal to 15.33 something. Is it clear? Because 3 15s will be 45, you will have 1 by 3 is 0.33. So average waiting time for each process to complete them using the shortest remaining time for scheduling algorithm is 15.33. I hope you have understood how I solve this question. If you still have any doubts related to this concept or related to this question, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.